Alright, welcome back to our discussion on sum and difference formulas. Last time we looked at why we need those formulas, because the distributive property of multiplication only applies for multiplication. And we also looked at kind of deriving those same formulas. That's where we left off, really. We ended here on the sum formula for tangent, which I don't really want to say too much about, short of the fact that I have sine over cosine. And these expressions were the values we found for the sine sum formula and the cosine sum formula. So after substitution, I would end up at that line. And then, to kind of be clever, what people did was they multiplied both top and bottom by the same thing. They multiplied by 1 over cosine A cosine B, and they did that because that reduces all this mess to just be tangent of A plus tangent of B over 1 minus tangent A tangent B. So that's kind of nice, that's kind of useful. But really all of this here is just a lot of algebraic manipulation to simplify down. So where we go from here is needing to go from a sum of two things inside of a tangent or inside of a cosine to a difference of two things. So instead of looking at sine of A plus B, let's look at sine of A minus B. Before I get there, though, I want us to briefly recall something we had talked about some time ago, and that was about the even and oddness of the trigonometric functions. Right, so on our unit circle approach, we start at 1, 0, and let's say I rotate some amount theta, or I move some distance theta about the unit circle. Well, that ends me up here at x, y. Well, suppose instead I had gone clockwise by that same amount. I had gone negative theta. Then I would end up at this point here, which is x, negative y. So the cosine for theta, or I guess in general cosine x, is going to have the same value for either point. Whichever way we rotate, we always have the same x coordinate. So cosine of negative x is actually the same as cosine x. That's why we call cosine an even function, because it kind of behaves like y equal x squared. It has that same symmetry to it. Conversely, though, on the other side of it, if I had gone positive x or negative x in rotation, that gives me the mirror opposite y coordinate. And that's why we say, well, the value for sine of negative x is the opposite of what I would have gotten for sine of x, where x is the number I rotate around by. And also recognizing that tangent is sine over cosine, sine being odd, cosine being even, I have tangent of negative x being negative tangent of x. So we have that property for sine and tangent, and the even property for cosine. And I say all that because now we've got all the machinery in place that we'll need to derive the difference formulas. Specifically, well, I've got sine of A minus B. Well, that's the same as sine of A plus negative B. So substituting into our existing sum formula, sine A, cosine negative B, cosine A, sine of negative B. And then, using our even-odd identities, cosine of negative B, that's just cosine B. Sine of negative B, well, that's sine of B, but negative. So this plus becomes a minus. And we do very similar things for all of our other identities. Right? Cosine of A minus B becomes cosine A cosine B plus sine A sine B. And tangent of A minus B becomes tangent of A minus tangent of B all over 1 plus tangent A tan B. So we kind of flip the SIGN. We flip the SIGN signs of each of our identities. That's kind of handy. And I think that's all we're going to need, right? Because we don't have anything special for secant or cosecant or cotangent, and I'll get to why here in a second. First of all, though, let's just get this to practical use. Let's say I wanted to find the cosine of 75 degrees once and for all, and do it exactly. None of this 0.258 business. I want to find it exactly. Well, the way I would go about doing that is like we've done before. A cosine of 75 degrees is, yes, the cosine of 30 plus the cosine of 45, except not with this distribution nonsense. Instead, with this application of the sum formula. Cosine of a sum of two angles is cosine cosine minus sine sine. So we apply that formula, and then we apply the cosine and the sine to each of these angles, and we get square root of 6 over 4 minus the square root of 2 over 4, which is root 6 minus root 2 over 4, and that is the exact value that you would get for cosine of 75 degrees. If you want a decimal approximation, it still would be the 0.259 thing, but now we know exactly what it is to an infinite number of significant digits, and that's pretty cool. That's pretty good. Good for us. On the other side of it, what if I wanted to find tangent of negative 105? Well, I could say, well, negative 105 is tangent of 30 minus tangent of 135. Well, not really tangent minus tangent, but rather tangent of 30 minus 135. And that's going to be, after applying the difference formula for tangent, tangent of 30 minus tangent of 135 over 1 plus tangent of 30, tangent of 135. And we apply all of our tangents for all of these angles, and I get root 2 over root 3 for the tangent of 30s, and negative 1 for the tangent of 135s. And applying a little bit of algebra will get us everything else we need. What is this? I don't want to see the main toolbar. So that's what we've got. Which, by the way, comes out to just be 2 plus the square root of 3. Don't think any one of us would have guessed that. And if you want the approximate version, it's 3.73, give or take. So fantastic. Of course, we do have a lot of options available to us, right? You can use any coterminal angle you want whenever you're using, well, any trig function, really. So if you want to find cosine of negative 15 degrees, you could argue, well, that's 30 minus 45 degrees, and that would get you to 6 plus root 2 over 4. Or you could recognize, oh, well, that's the same as cosine of 345, which is 300 plus 45, because 345 is coterminal with 15 degrees, and that too would get you the same value, root 2 plus root 6 over 4, the way you evaluate that. So you do have options even here, but even though there's infinitely many ways to do it, that also means there's infinitely many ways not to do it, right? You can't just distribute the cosine across. This does not equal cosine of 30 minus cosine of 45 degrees. Instead, it equals cosine 30, cosine 45, plus sine 30, sine 45. Skip. That's next time. And I know what you're wondering. Am I going to have to memorize all this? Am I going to have to keep all these sine A, sine B, cosine A, cosine B's? Am I going to have to keep all that straight in my head? And the answer is no, not in this class. In this class, I'm just going to give them to you because there's not a lot of value in memorizing all the sum and difference formulas. That's not even really a thing that comes up in Calc 1 or Calc 2, except for, well, no, not even then, I don't think. So I don't think it really comes up in those classes. And if it does, way down the road for very specific professors doing very specific things, well, if you have to memorize it then, I trust you to do it then. For the here and now, though, what I expect you to be able to do is say, okay, I need to find the cosine of 15 degrees or the cosine of negative 15 degrees. How do I do that? And this is one very easy way of doing that. And that's the expectation I have for you. So ends this video on the difference formulas and also on using these sum and difference formulas to evaluate trig functions exactly for more values. In the next video, of course, we will turn our attention back to using this to prove more identities, doing more proofs, kind of like we did at the first section towards the end of that. So too we will do with sum and difference formulas. So look forward to that. See you then.